and the approach that we are going to take for deletion is the same. So we will take one previous pointer, one current pointer. Current pointer is the one that will keep on moving, and previous pointer will always ensure whenever we move current, previous moves to the previous of it. So if this is the approach we are taking, that means we need LL node star current and star previous. This is important to remember that star we have to put with both of them to mark them as a pointer. In beginning, previous will be initialized to null, current will be head. Clear? And we want to go to each and every node because we have to account for deletion of even last node. So we'll say while current is not equal to null, so we keep on moving. So that is the loop we'll do. Now if current of data matches our data, that is when we have to take delete action. If that is not the case, what we do? We move. In else case, current will move to current next, and before we change current, previous should get the current value, so that previous is always one step behind current. So this is clear. So let's come to this matching case. When the data is found, first thing we have to do is previous node should point to next. In our animation, if we see, after we find 3, first modification we do is to previous of next start pointing to current of next. So that is the change we'll code. Previous of next is current of next, and after doing that we have to free this. So free a node which current is pointing to. So free is a function similar to malloc, and to free, if we give the node address which is current, it is going to free that. So after we have freed this, deletion has happened. Who is the head of linked list now? The original head, right? So here we return head because we don't need to proceed any further. We are deleting the node and returning. Otherwise, this loop will continue on running. If this match is not found, this loop will break when current is null. When current reaches in the end, so we come here. If node is not found, this function is going to return something that head will be updated with. So what should we return? Null. If we are going to delete a value 10 from a linked list 1, 2, 3, now 10 is not found, return head, because if I return null, then I'm kind of losing all my linked list. So if the node is not found, my linked list should remain unchanged. So what should we return here? Head. So that we have to remember, should be head. With this it should work fine, right? So let's go to main, make a call. So first we are traversing, that means linked list will be printed, then we are deleting, then we are traversing again. So let's run it. Okay, in previous function that you are writing some. So this is a function that Ajay was coding. Let me comment it out for the time being because it was incomplete, right? So let's compile it first. So no errors, no warnings. Now let's run it. So first linked list was 1, 2, 3, 4, 5. Then we deleted 3. Now it remained 1, 2, 4, 5. But now we should validate all our interesting cases. So what are the interesting cases for deletion? Delete first node, because that is the case where head is modified. Delete last node, delete middle, delete a known existing value, delete from null list or blank list. These 5 cases we will test with. So middle is tested by passing 3, right? So when we ran just now, we have handled a case of in between.
Yes.
Now we want to run with 1. Because we have not handled all the cases, we expect this will not run fine in all the cases. So let's give 1. Now what we expect? First traverse should print 1, 2, 3, 4, 5. Second traverse should print 2, 3, 4, 5. Let's run it and see. Crash. So there is a problem. Why there is a problem? Now we need to understand. So let's go to our delete function that we have coded, and let's add a breakpoint here, and to understand why it is crashing when we are deleting first node. So let's run it. We are at this line. First traverse has printed 1, 2, 3, 4, 5. Now we are passing in data, we are passing, what are we going to delete? 1. In head, the head of the linked list has come. So now let me add watches here. Our current is pointing to head. So let me put star current. Current is having value 1. So we come to this line, condition is true. We get inside, current data matches data. Right, Ajay? Current data is matching data because current is pointing to the head. So that is equal to 1. So what we do? We go inside. Previous of next. Who was previous? Null. So what are we going to do here? We are dereferencing a null. And crash will happen at this line. So if I do F7, we see a crash. This is segmentation fault. So that means if it is first node, then this logic is not the right one to proceed with. So let's handle that case separately. So can we say if head of data equals data. If the first node is the one that we want to delete, then we will not go into the loop. So what should we do here?
Assign to variable first value.
So we should be freeing head,
Yes.
and then we should be returning head of next.
Yes.
This is clear? Because second node is head now. So can I say free of head and return head of next? Right? Anisha? But we are freeing a memory and after that we are accessing it. This will also crash. So we should never access a memory after we have freed it, because after freeing it's no more our memory.
Initialize it to somewhere.
Yeah. So basically before freeing it we should assign head of next to some variable. Since we have current and previous, let's make current equals, we first preserve the next value, and after that if we free it's fine, and then we can return current. So that way we are not touching this memory. The next portion of that we have accessed, we got the address, we assign to current. So this way we have fixed this issue. If it is first node to delete, then this is the piece that will execute, we will not go into the while loop. So now let's run our code and see. One is deleted. Fine. Now we have validated first node, middle node. Let's go to last node. If we are deleting 5, let's run it. It deletes 5 without fail, because there we know our logic is simply we are sitting on a previous node, we are modifying that to point to next, and that will be sitting on 4 when we say, let me go to the code. Sitting on 4 when we say previous of next is equal to current ka next. Current is pointing to 5. Previous is pointing to 4. Previous of next we are changing to current next. Current next is 5, next is null. 5 is the last node. So null we are assigning, no problem. Then we are freeing current and we are returning head. So this also works fine. Now third case. What is our third case? Third is done. Delete a non-existing value. If the value is not existing, let's say 15, we have seen the case we coded was, will come out of this loop with current is equal to null.
Yes,
And that way we are returning head. So head is the original head, so no modifications done. So let's run it. Same linked list is returned back. So this case is also handled. Now the last case. delete from a null linked list. That means if linked list is not there, we are deleting a value. This is one more case to handle. If this is null and if I run it, our program is going to crash. So now let's figure out from our code why it is crashing when head is null. So let's say I pass head null. First line, no effect. Second line, we are making assignments. So current also we are assigning null. Fourth line, what are we doing? We are dereferencing a null here. So before this, we should have checked if head itself is null, we can't do anything. There is nothing to delete, we handle that case. With this, if we run our last case, what are we doing? We got null, we have returned null. So we have not modified, we have modified head also in this case. Okay, so let's not modify head and let's take another head, so that we don't lose it. Our previous list is printed as is, because this changes we are doing not in our linked list. We are passing a null, that means an empty linked list. So now it does not leave any effect on our linked list. So these are the cases to think about and to handle when we are writing deletion. Any questions?